on this computer. All right. So here's where we are on February 26th. This is our review session. On Friday, we have our midterm and our sorting lab. Woohoo! Then we have a week off, right? These are the official days off for students at LSU. This is not an official day off, but I am going to be in Disney World. So you get that day off too. At least for the regular part of the day. There is going to be a lab, and the final project, 400 lines are going to be due. The TA should be at lab to help you. I will be playing hooky that day. All right. Oh, and then when we come back on March 10th, we'll be in 1100 PFT, not in this room. Oh my gosh. No more dungeon. All right. Okay, so let's get started. All right, so let's take a look at last year's midterm. Let's see what I thought up last year. I mean, let me back up a minute. Before I dive into that, does anybody have any specific question that they want to ask? All right, no, you all want to see the last year's midterm or last semester's midterm. Okay, so some people still don't get your IDs right. Just saying. All right, a student turned in an implementation of array list. They're told their instructions were to create an initially empty array that users could append to. They were told they should not need to allocate new memory with every addition. I think this is a repeat of something you've already seen. And what we're supposed to do is we're supposed to match what we're supposed to fill. Oh, you haven't seen this. This is a fill in the blank. Okay, so what I have here is a fill in the blank. So what goes in the blank on line 0? Implements, right. And what goes on line 1? Yeah, 0. And what goes on line 2? Wait a minute, what goes on line 2? Oh, yes. 10. 10 goes on line 2. And on 3, what goes on line 3? Logical size. And what goes on line 4? No. If logical size less than logical size is not the right thing. Data.length, yes. And then here, what goes here? It kind of doesn't matter. It's either logical size or data.length. They should be the same at this point. Add, what goes here? What's that? What goes on line 6? Logan. Logical size plus plus. Oh, logical size plus plus is actually the one we want. If you do the plus plus first, that increments before. So that would mean the first thing I fill in would be slot 1 instead of slot 0. All right. Line 7. What goes on line 7? Incorrect. Data.length is always greater than 0 because it is initialized at 10. Logical size. Yes. For I equal 1, I less than logical size. Go figure. All right. Okay, so that's that one. Any questions? All right, so here is sort of a here's another true false. Quick sort is an example of a recursive sort. True. Merge sort is an example of a recursive sort. True. The merge sort we studied in bubble sort is an example of a recursive sort. False. Selection sort is an example of a recursive sort. False. The merge sort we studied in class is stable. True. The quick sort we studied in class is stable. False. Merge sort uses a random number. False. Okay, so that's pretty easy. If you were just paying attention, right, you should be able to get those. There are a certain fraction of questions which you will get right if you just pay attention. Yes, Drew. What that means is if that values that are equal get shuffled around. So if you think back to the last class, we did this implementation of a rocket with compare to, right? Now I compared based on the size and the name of the rocket. But suppose I only compared based on one of those, right? And I had, say I only compared on the size. Now I have two rockets with the same size but different names. As far as the sorting is concerned, they're equal value. And that means they can get shuffled around by the sort. They won't necessarily stay in the same order at the end. Okay, that's what stability refers to, whether values that are the same stay the same. Or whether values that are the same stay in the same order. Okay. Which is an example of an anonymous inner class? Oh no, right? So we have public interface Zoom, int Excel, int N. So let's look at the first one. Keyword new needs to be there. Name of the thing we are extending needs to be there. Parentheses for the constructor need to be there. Open curly needs to be there because now we're going to implement the method body. The method has to be public because it's an interface. So public int Excel. It has to take an integer and return an integer. This one looks fine. Okay, so if I'm a student and I'm reading this, I've gone through my checklist of things I'm looking for, and they're all there. Maybe I missed something. I'm going to mark this one as a candidate, and then I'm going to look at the next one. New Zoom private. Whoops, private is a no-go. New Zoom, no parentheses for the constructor, no-go. New Zoom, no parentheses. New Zoom, int Excel, no public. New Zoom, int run. What's run? Where did that come from? It's not public either. What is that? And this one, where's the method? We just put a return inside the curlies. It's just wrong. So the first one was in fact correct. Make sense? So there's that checklist in your mind. Keyword new, the thing we're extending, parentheses for the constructor, open curly, implementation of the methods, public if they have to be, right? Are we good? All right. Merge sort. So we have a merge sort routine here, and we want to ask true false questions about it. And this is a super abbreviated one because look, we've just got this word merge that we use and we pass two lists to it. So that's leaving out some details for us. Let's see how this goes. So first thing is this merge sort routine correct? No, what's wrong? Who can tell me what's wrong with it? You shook your head. What's your name? Simeon? Yeah. What's wrong with it? Yeah, the formula is wrong, right? The formula for the midpoint is wrong. It's end minus start over 2. That's just wacky. So what we want is parentheses end plus start over 2. Or alternatively, we want start plus end minus start over 2, right? One of those two things would be the correct thing. Everybody see that? All right, I'm gonna undo that. All right, so it's not correct. This merge sort is missing a special case for end minus start less than 2. Yeah. This is infinite recursion, isn't it? So in addition to having that midpoint wrong, it's got infinite recursion. The value of mid should be n plus start over 2. Yep. The value of the mid should be n minus start over 2. Nope. Sublist low should be sublist to mid minus 1 and then mid to end. No, right? That's correct. What's up here is correct. The merge sort should not be static. Why not? Doesn't need any state from the class, so static is fine. All the lists should be replaced by array lists. Well, no, that wouldn't really help anything. Okay. Any questions there? This is your chance to ask questions so that you will not get things wrong. Which would you rather do? Would you rather get something wrong? Yes, JJ.
Can you just go over why the low and high are those specific sorts?
Right. So the point is, right, what we're trying to do with a merge sort is we're trying to divide the array into 2 piles.
Right.
So what sublist is going to do is it's going to go from start to mid where it doesn't include mid, right? It goes up to but not including mid. But I need to include every element from start to end where I'm not including end, right? So this is the thing that does it. Yeah, as I was saying, which would you rather do? Would you rather look stupid because you asked me a question in the room in front of everybody, or get it wrong on the exam? Hopefully, you would prefer to look stupid. But the thing is, you won't actually look stupid. That's the thing that's hard to appreciate. There was I forget who it said it was. Who said it? It was, when you're 20, you worry about what everybody's thinking of you. When you're 40, you stop worrying about what people are thinking of you. When you're 60, you realize that nobody was ever thinking of you in the first place. Okay, so just try to keep that in mind. All right. Any questions? Yes, Vanek.
So why didn't you put midpoint right in there? Doesn't the size method for array list return it?
Okay, so look at my sort method, right? I have a sort of a list from a start to an end position. I'm sorting the elements from the start to the end. I need to make all my recursive sorts work that way. Right. Okay. All right. So the next question is hello. Remember hello? Remember that recursive program, hello? And you had to keep track of which side of the recursion your print statement was on, right? You had to think that through. And here is a hello. Well, hopefully you're not memorizing that. Hopefully you're thinking it through. But here is that hello program, and we want to know what the output is going to be. All right. So this is testing whether you understand some fundamental behavior of recursion. So we're going to start with hello 3, right? And this is the way you should approach all the code problems that say, what is the output? Is you should pretend you are a computer and you should attempt to execute them. If you try to skip over doing that, you're going to get it wrong. Okay, so I'm starting with 3. So I go here, right, with 3. Is 3 equal to 0? No, so I don't do this bracketed step. So the next thing I'm going to do is I'm going to print out 3. So the right answer is going to start with 3. Okay, so I've already cut it down to just 2 options. All right. Now I'm going to call hello n minus 1. So now I'm going to call hello with 2. Okay, so I've called hello with 2. And is 2 equal to 0? No. So I skip down to here and I print out the 2. So I have 3, 2. That doesn't help me. Both of these are like that. Then I'm going to call with 1. And I get 3, 2, 1. That still doesn't help me, right? Now I'm going to call with 0. Which of these will I get? Yeah, I'm going to get the exclamation point, because what's going to happen is I'm going to go in here with 0. I'm going to say if it's 0, print the exclamation point and return. So just by following through what the code is doing, I can determine which output is correct. But if I don't follow it through, if I just sort of look at the code and try to intuit it, you're almost guaranteed to get it wrong. Okay, any questions on that? All right, we are moving on. Oh, yeah. Now we have a different question. Like that? It's a different question. Looks kind of similar though. Yeah, okay. So let's see what happens. All right. So I get hello with 3. All right. So I call hello with 3. Is 3 equal to 0? No. So I call hello with 2. So I call hello with 2. Is is it equal to is 2 equal to 0? No. So I call hello with 1. I go up to here with 1. Is 1 equal to 0? No. So I call 0. I call 0. I print the exclamation mark. So the exclamation mark comes first. But now I'm going to, but now, right, I've got, but now I'm going to go back down the stack. Now 0 didn't print. So this one didn't happen. But the next one, the 1 is going to happen. So I'm going to get this one. Right? And I mean, if I was a student, I would be making little paper annotations for each stack call so that I could track it a little more easily, a little bit more organizedly than just sort of verbally going over it. But you can see what happens. I see people shaking. Yes, Vanek. There's only one difference. Okay. This one has hello and print. And this one has print and hello. That's the difference, right? The difference is whether I print while I'm going up the stack or I print whether I'm going down the stack. Yes, Michael, right? Well, whatever you want. So the question is whether there's a benefit to doing one or the other. And you know, it just depends on what you're trying to accomplish with the program, right? I mean, sometimes counting down is the thing you want. Sometimes counting up is the thing you want. If we look at the merge sort, right, we do the recursive calls first, and then we merge. If we do the quick sort, we partition, and then we recurse, right? So which one you want depends on the situation. If you tried to do a merge sort, you tried to merge first and then do the recursive part, it wouldn't work. You just get, you know, something random. So it depends on what you're trying to do. You have to look at the logic of the individual code. Any other questions? Are you all getting scared? Yes, Olivia. Yes. Okay. So of the second one? All right. So, all right. So I'm just gonna make some little notations on the side as I go through. So I'm gonna call, so what the first thing I'm gonna do is I'm gonna start with 3. So I'm gonna say n equal 3, right? And if I go to n equal 3, if n is equal to 3, I say if n is 0, and it's not. So I go to the next one, which means hello 2. So then I'm going to put the n equal 2 there, right? And now I'm back up to here with n is 2. Is 2 equal to 0? No, it's not. So I skip over those. I go to here. I call with n equal 1. All right, now I'm back up here again. I'm calling, I have a 1. Is 1 equal to 0? No, it's not. So I'm going to go down to here. So now I'm going to call with n equals 0. Okay, with n equals 0, actually, let's change these things to these things. All right, I'll just do it this way. So when I'm doing the open parentheses to tell myself that I've started the call into the subroutine. So okay, so I've got 0, right? I've got to n equals 0. Now I'm going to print. I'm going to print the exclamation mark, right? So I can notate that to myself and however I want to do it. I can say I'm printing the exclamation mark. And now I'm back. Now I'm going back to where n equals 1. I'm picking up from here when n equals 1. And we say 1. So this is going to be 1, right? And already by this point, I have eliminated all the answers except this last one. Does that help? So you have to just sort of make a note, you know, I start the method call, I get at n equal 3. I recurse into the method call with n equal 2. I recurse into the call with n equal 1. I recurse in with 0. Now I print exclamation mark and return. I go back to this n equal 1, 1. I print the 1 and I'm done. Make sense? We all good? Yes, Vanek.
So the first one prints as you build a call stack. The second one prints as you unwind the call stack.
Yes, the question is the first one builds as you the first one prints as you build the call stack. The second one prints as you unwind the call stack. That's correct. And I sort of gave them both. I gave them both to the students because that way I'd forced them to focus on the subtle point of the order of those two things. They didn't allow them to gloss over it. They could see two things that look almost identical, and then you have to say, well, what's different and how does it change the behavior? So that was, in a way, that was me trying to help. All right. Any other questions? True or false? Shuffle answer. Oh, okay. So, all right. So what I'm going to do, right, is I have a recursive problem here, and it's going to print out true or false. And then I have to pick the ones that pick the statements that are actually going to print. So let's look at this. This is a group sum problem. This is a variant on the one that on the one that I have showed you before, right? Where you try to find out if all the integers together can make up the thing, right? And if you look at this code, what it's doing, right, is it's saying if the next, so if you look at just these two lines, right, this is kind of the same thing that you always see. This is if I left out this line here, right, everything would just be normal, right? N would be 1, and I would look at the next thing, and it would just be the normal thing, do the integers add up. But what this line changes, right, is I'm looking at the next character position. If the next character position is inside the array, and if that value is divisible by 3, then I'm going to skip it. So this is telling me that I can add up, take any integers to make up the sum. But if I pick an integer and the next one is 3, then I have to skip it. All right. So can I make 1 from 1, 5, and 3? Yes. Can I make 4 from 1, 5, and 3? Yes. I can use 1 and 3. Can I make 6 from 1, 5, and 3? Well, so if I use 1, I have to check, is 5 divisible by 3? And it's not. So I think I can. Right. So that does work. Right. And 5 is not divisible by 3. But 3 isn't the next one. It's the next after the next. So look, I'm trying to make 6, right? So I use 1 and 5. I don't need the 3. All right, but now I want to make 8. Now I have to add them all together, or I have to add the last 2 together to make 8, and that's not going to work, right? Because I can't use the next one if it's divisible by 3. And this next one, I want to make 28. Well, okay, so 5, 3, and 8 would do it, but I can't do that. You know, can I figure out some other way? I don't think so, right? So I could make 6 and I could make 6 and 21. It's just not going to work out. Can I make 29? Okay, so 29, I could use 5, 3, and 21. Except if I use the 5, I can't use the 3. So I think I'm pretty much stuck with using the 3 for these two. Can I make 23? Well, 23, I can just use the 3 and the 20. So that's going to work. Okay. Yes. What's your name? Lillian. Right. If it's the one right after is divisible by 3, then I can't use it. And it's just one line of code that's different from the one I showed you in class. But, you know, it's a tricky line of code. So be on your toes. Some problems are harder than others. I think this is probably the hardest problem on this test. Any other questions? All right. Okay, so this is a Fibonacci, and this has got my error in it that for some reason, I don't know why I did this, but let me fix it now. Okay, so we're going to compute a Fibonacci sequence. First two numbers are 0 and 1. What's the missing line? I think you had this exact problem, right? We want the sum of the two previous integers to be added, and that's that. Any questions? All right. Identify the primitive types. Hopefully you know the primitive types. If you miss the primitive types on this midterm, if I ask you the primitive types and you miss them, you have to ask yourself about your life choices. It's something in C++. It's not something in Java. Well, and in C++, you'd put a space, so it's not even a thing there. It's just a thing. It's just craziness. It's a trap for the unwary. Look, I mean, I don't want you to kind of know what the primitive types are, right? And if I invent something just out of nowhere, you should realize, hey, this thing doesn't belong. All right. What is the output of the following code? This is to test if you understand how Inker works, right? The answer is going to be 4. Because why? Because primitive types pass by value. This is also one that you should like thump yourself hard in the head if you miss, right? We've had like 3 questions on this, and I've discussed it at length in lecture. What is the output of the following code? Okay, so there's a bunch of similar things here. So let's see what we can do with that. So we start with an array that's 1, 2, 3, 4, 5. All right, we're going to set I equal to 2. Then we're going to say Z of I plus 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 plus. So we're going to take Z of 2, which is which one? 3, right? So we're going to increment that one to 4. So keeping track of what we're doing. Hold on. 1, 2, 3, 4, 5. So what we're doing is we're going to increment this one to 4, but now I is going to be 4, right? And now I'm going to do a plus 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 plus, right? So that's going to mean that this is going to evaluate to a 5. 2, 3. No, I'm sorry. 2, 3, 4. It's a 4. Sorry. It's a 4, and then I'm going to plus plus that. So I get this. You follow that? Yes, Michael.
Can you go over that one more time?
Yeah, so I start with this, right? I is 2. Now this one is going to increment the 2 position and increment the I. So I is now going to be 3, right? And I'm going to go up to here. and increment that, right? Because this I plus plus is going to return a 2, but it's going to also increment I. Now, when I put the plus plus in the front, I increment before I return it. So I'm going to take that 3 and make it into a 4. And then I'm going to increment the thing at position 4. The thing at position 4 is 5. And so I make that 6, right? And so this is what I get. It all makes sense. Yes.
So even if you have the plus plus like before or after, like it will still like increase it by 1.
Yes. What's your name?
Bennett.
Okay. So Bennett asked if whether plus plus is before or after, it still gets increased by 1, and that's the case. The only difference is what gets returned. Yes, Ty. Inside bracket out. I'm not sorry. I don't understand. Yeah. Oh, the inside part gets done first because it has to know which thing to increment. So it has to do the inside one first. No. So the way Java has to work, right? The way it has to work is if it wants to increment Z, it has to know what index to use, right? And so it has to calculate the index first.
But if that plus plus Z bracket plus plus I was inside of another thing,
it must compute the index before it can do anything to the array. So it's got to go inside out. Yes, Michael.
I don't know if it's not understanding the Z. I understand the index. I had said that square bracket, but plus plus.
So prefix or postfix of plus plus just means whether we return the value that we incremented or whether we return the original value. So
that's what changes the number. Say 3 to 4, 5 to 4.
the plus plus is always going to increment by 1. It's just a question of the order of what my return value and my incrementing step. You don't get it. So if I put a plus plus here, if I put a plus plus I, right, then I would have incremented this one instead. Right. So that's the difference. And it always evaluates from the inside out. You always have to calculate the index first before of something that you're indexing. If you have a function, you have to calculate the function arguments before you can call the function, right? It always has to work that way. Otherwise, it just wouldn't be able to function. Questions? Are you getting excited about this exam yet? Oh, yeah. All right. True, false. Look at that. Another true, false. Java relies on multiple inheritance. False. A class can only implement one class. False. A class can only extend one class. True. A constructor has a return type of void. False. A constructor does not need curly braces. False. A class can implement many interfaces. True. A class can extend many interfaces. False. A constructor is a static method. False. Hopefully you knew all that. Another what's the output question? Static int A, int B, constructor with B equal A plus A plus B plus. We have a main method. Now I could use a drink. Stat in 1 equals new statin, and S2 equals new statin, and S3 equals new statin. Now we print out B, S1.B, S2.B, S3.A. Wow. Okay, lots of stuff. So when I call the first stat in, when I call the first constructor, I'm going to say B equals A. What is A initially? 0. Okay, so B is equal to 0 and A is equal to 0. So I get A is 1 and B is 1 at the end of this call, correct? All right, now statin 2. Statin 2 is going to get a new copy of B, right? But it's going to use the same copy of A because A is static. So A is 1, right? So let's keep track of this. So statin 1 has A equal 1, and I'm going to put out the front B is equal to 1, right? Now we're going to do statin 2, and statin 2 is going to initialize B with 1, right? And then it's going to increment them both. So it's going to have A equal 2, but now B is equal to 1, right? Right? No? Yes. So read. I just stepped on some pencil and broke it, I think. All right. Oh, maybe not. I don't know. All right. So step 1, A and B are both 0. I call the constructor B is equal to 0. I'm calling the constructor A is initially equal to 0. I increment A. I increment B. I call statin 2. Okay, I set A from B. A is equal to 2, or A is equal to 1. All right, now I increment A to 2 and B to 2. Right? Because B doesn't live inside the class, but A does. One is static, one is not. That's the point. Okay, then I'm going to call constructor statin 3. I'm going to initialize A from B. A is going to be 2. And now I'm going to increment this to 3. And I'm going to increment B to 3. Okay, so S1.B, what's that? It's 3. Look, I have it written here. B equals equal to 3, and it's a static.
A's static, B's not.
Oh, I'm sorry. I was doing it backwards. Why was I doing that? Okay, let me just, okay, that's why I was getting confused faces, I guess. I was doing it backwards. Thank you. A is equal to A. Okay, let's just start over. A equals 0, S1, all right. B is equal to 0. Turn them. I had swapped A and B in my mind. S2, right? We're going to say B is equal to 2, or is equal to 1. We're going to increment both things. All right, and then we're going to do S3. We're going to say B is equal to 2. And then we're going to increment both things. So that's 3 and that's 3. All right, now S1.B, 1. S2.B, S3.A. So that's what it should be. It should be 1, 2, 3. Feel better? I'm sorry. All right, bubble sorter. Fill in the missing code. Ooh. So I expect you to know how these sorters work. You can't do these problems if you don't know how these sorters work. So just keep that in mind. When I show you code in class, I expect you to know how it works. All right, so Boolean is going to be initialized to what? False, right? Because otherwise nothing happens at all. So hopefully that's a no-brainer. The next thing I'm going to do is do what? Done equals true, right? I want the done to be set to true. And if I go to swap something, then I know that I need to do more work. That's the way this works. So I'm going to go from I equal 1. I'm going to go from I equal 1 to what? Array.length. right? So I'm going to go from I equal 1 to array dot length. And then on this one, what am I going to do? Array of I minus 1. I think somebody said that. I want array of I minus 1. I want to see if they're out of order. If they are, I'm going to swap them. Okay. And then on line 5, I'm going to do what? Done equal to false. See, that wasn't so hard, right? If you know what a bubble sorter is and how it works, it's not that hard. Yes, Mike.
The logic would be using the false. Where it's like saying that it's true.
Yeah, we're setting it to true. When we get inside the loop, as soon as we start, we set it to true. And only if we find something that we need to swap do we set it to false. And once we know that we've actually made a change in the array, we know that we had better keep going.
So it's initially false, and then it's because all of them
You-
switch it to true.
Yes,
And then you make it true.
right?
Will that like check?
So look, I'm going to make it false here, right? I'm going to make it false if I do a swap. The point is, if I can get through the loop without making a swap, I'm done. Okay. All right. Fill in the blanks. We have a selection sorter. Ooh, what fun. All right. So I, right? That's kind of a no-brainer. All right. I'm in is equal to I, right? We're going to start with the current position. We're going to assume the current position is going to be the minimum to begin with. Then we're going to say what? I plus 1, right? Because we want to start with the next one. We want to compare with the next one, not the current one. So we want I plus 1. And here, right, we're going to have what? I'm in, right? We want to find out if we're less than I'm in. We want to find the minimum value, and I'm in is keeping track of that. And oh, this line means I would accept either of these answers. Because if you put I, it's kind of a wasted step, but it's not wrong. It won't give you a wrong answer at the end of the day. It'll just be slightly less efficient. And then in this one, I'm going to say what? I'm in, right? Because that's going to be, because that's now the new minimum location. Make sense? All right. Oh, and then there's a 6. Swap I'm in and I, right? So at the end of this for loop here, I have to put the minimum value in its proper place. I said I'm swapping at the end, I'm swapping I'm in and I. Oh, it's I plus 1. I'm sorry. I think either one will work, to be honest with you. I think either one of those will work. So yeah, because this is just stopping one short of the end, right, with an I plus 1. So it's an efficiency issue, right? If B is going to start with I plus 1, it's going to never execute at all, and nothing's going to happen, right? It's another efficiency issue. I could put it in, I could probably just put that like this here. Shouldn't matter. What's your name? Nathan. Does that make sense? Yes. What's your name again? Kobe.
So in line 2, you're setting I to I. So on line 4, 5, why can't you use I?
What I'm trying to do, the purpose of the loop is I'm trying to find the minimum from I forward, right? And if I use I, I'm not updating I'm in, right? I'm in is the thing I care about. The logic of the sort is I want to find I'm in so I know what to swap with. So if I put I, it's just the wrong thing. Yes, and I know you just told me, Lillian, right? Yeah, they should both work. I mean, the sort should work both ways. Yes, Olivia. If I give a, so the way this is coded in my answer key, it's going to give you credit if you put either of those. Right? So what I want is code that's correct. I'm not going to be, oh, it's 0 credit if it's inefficient because you checked it, you compared an integer an extra time. I mean, I know there are instructors who think that way. I just don't share that viewpoint. Okay, so if the sort works correctly and it's not egregiously inefficient, right, then it's fine. And let's see, is there anything else in this? Yeah, that's the end of the exam. All right. So how would you all have done? Would you all have gotten A's? Yeah, I'm sorry. So I was just Ding was just saying he noticed a lack of big O questions. You're probably going to get big O questions. You know, every time you go through one of these classes, things happen in different orders because of different things that are going on. And when I get to the midterm, I'm at different points and different amounts of material has been covered. So please be aware that big O questions will be potentially there. Yeah, I will send you an email like I did. You know, I'll send you a zip file with this test and all the quizzes. All right. Yes. Yes, I'm planning to have 35 bubbles filled in.